In this question, we're trying to match each of these graphs that are given with its corresponding equation. Now, the most useful thing to keep in mind here is that when you see a cosine and a sine pair, that is in a parametric equation, that's generally going to give you rotation. And that goes back to the idea that on a circle, if we imagine t being sort of like the angle, that the coordinates of a point on a circle would be cosine t and sine t, right? So when we have a cosine and a sine pair in an equation, it suggests to us rotation. So, and you'll notice we see lots of cosine and sine pairs here. Keep in mind also that if you have something multiplying in front of the cosine and sine, that's going to act like a radius. So if I look at my equations here, I notice that, this one, and this one all have a cosine and sine pair that don't have a radius on them, right? So the radius isn't changing, radius would be constant at 1. Whereas the one on the top here and the one on the bottom here both have a t multiplying the sine or cosine, which is going to change the radius. So I would expect the top and bottom equations to have graphs that look more like spirals rather than something more circular in shape. So if we look at our equations here, notice that at least in x and y, this one is fairly circular in shape, as is that one, as is, well, maybe not in x and y, but from the other sides, this one's fairly circular, while these two definitely appear a bit more spiral shaped. So I would expect these two to match up with the top and the bottom equations. Now let's see how these two are different. Both of them have a t multiplying the cosine and sine, which means as t increases, the radius will increase. In the bottom equation here, z is increasing at the same rate as the radius, whereas in the top equation, the z value is increasing faster than the radius. So if I were to look at both of these graphs from the side, I'll notice that in this equation, the z value and radius are increasing at about the same rate, while in this equation, the z value seems to be increasing faster than the radius. And so because the z value is increasing faster than the radius here, that's going to correspond with this top equation. This one, they're increasing at the same rate, and so that's going to correspond with this equation. Now, if we look at the remaining three equations, in the middle one here, I notice that again we have a t in the z component, which means the z value is going to just steadily increase as t goes on. Here, it looks like my z value is going up and down. Here, my z value again appears to be going up and down, not just steadily increasing, whereas in this equation, this is sort of a classic helix, the z value is just increasing as t increases. And so it looks like this graph here is going to correspond with this equation, a standard helix, circular rotation in x and y, increasing in z. Now if we look at the remaining two equations, this bottom one has the z value oscillating like a cosine function up and down at a rate 3 times bigger than the rotation of x and y. Whereas in the top equation, actually it looks like in this one that we have a cosine and sine pair in x and z, and also in y and z, but that x is equal to y. And interestingly, if you look at these graphs, notice in this one, if we rotate it just to see x and y, we'll see that x is indeed equal to y, and we've got a circle in x and z. Oh, sorry, that was y and z, and another circle in x and z, right? So here's my x is equal to y, right? Let me see if I can get my pen back on here. So here, right, x is equal to y, and then we also have, sorry, having some difficulty with colors here. And then we also have x and z being a cosine and sine pair, right? So we're getting that rotation in x and z, right? And so it looks like equation D here is that one. Meanwhile, our last equation here, we can see that as we're rotating and getting our circle in x and y, our z is going to oscillate up and down 3 times faster, right? So as we're going around in x and y, my z is going up and down and up and down and up and down 3 times, right? And so that must be the equation for that one. Right, so that's the idea of how to do this matching. You want to look for that cosine and sine pair to look for rotations. You want to see, are they being multiplied by t? So is the radius going to be changing? And then look at how the other component, like in this case the z component, is changing relative to the radius.